Hey guys, so this video is going to be about recurrence relations. I would suggest watching my video on complexity. I don't touch on recurrence relations in that video, but it's some good info and it's pretty sweet, and you get to listen to my droning voice some more. So let's get started. I'm going to type out a function here, so I'm going to cut out for a sec. Okay, so I'm going to briefly explain this function. So we're finding an item in a given array, and we're returning bad if we can't find it, and we're returning good if we can find it. So the base cases here are these two at the top. So if the array is empty, obviously we can't find the item, so we're returning bad. It wasn't found. It just straight up wasn't found. If the item is at the first cell in the array, then we found it, and that's good. So the idea is to chop down the array one by one until our item is the first cell in our array. So let's say we have an array here, 5-cell array. Every single iteration of this, all but first, will take out the first element. This is only if we don't find it in the first cell. And now we're returning this array. It's going to get back plugged in to find. This is what recursion is going to get plugged in to find again. If it doesn't find it in the first cell, we take that cell out. If it doesn't find it, so let's say we found it now. We return good. It's right here. That kind of looks like a boob. And actually, to keep this PG, let's say it looks like an eyeball. But I digress. We forget about this last cell because we already found our item. It's in the first cell of our new array that was formed using all but first. Okay, so now that we know that, we can get down to the nitty-gritty, the recurrence relation. So the recurrence relation for this is going to start out a little bit tricky in the sense that this line here is actually not a computation. And in terms of complexity, it will be 0. There's no calculations, no computations done, so 0 computations. Here, however, we have a comparison, so that's going to be 1 computation. So when we start out our recurrence relation, it will be 1 plus what we have down here. So in recurrence relations, you should be renaming your functions to single letter variables. So let's call find t, and all but first will be n minus 1. So we don't really have to put I in there because this is a recurrence relation, so it's mathematical. We're not doing programming for the recurrence relation. So I'm going to scooch this up here and explain it just a little bit further. So when we're calling find, again, if we call it t, for the very first time, we have an argument n. Let's just, for the sake of argument, let's pretend that this is our array A. When we want to do the recursion, we call all but first, we're subtracting 1 element from A, which means that when we call the recursion, it will be n minus 1, because we're taking 1 cell off of n. So if we take what we have so far for our recurrence relation up here, and we repeat it for every single time that we do our recursion, we'll end up with 1 plus 1, because this 1 up here, this line, oh, I did not circle that very well. This line happens every single time we call the recursion, right? And since it has a complexity of 1, then we're doing 1 plus 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 1 for every single time that we call the recursion. So I'm going to put a plus here and some dots. and a plus here. Now we have to worry about this. So we're going to end up with n minus 1, minus 1, minus 1, minus 1, minus 1, minus 1, minus 1. Because remember, when we're calling all but first, it's taking off a cell off of our array A. And every single time it does that, n gets reduced by 1. So every single time we loop through the recursion, we're taking out a cell from A. So it's n minus 1, minus 1, minus 1, minus 1. So as we know from math, which we all love, when we have a ton of 1s here, we can just call that n. So t plus, or n plus t. Oh, nope, sorry, scrap that. It's not n yet, because we can't forget that we're working with t of n. So, sorry, just to clarify. I hate it when people mess up in videos, so I'm really sorry. Just to clarify, we're working with t of n. So, within t of n, within the function, here we're calling n minus 1 within t of n, right? So, all but first, here, will be called, and it will make n minus 1 because we're taking off one cell off of A. So t of n, instead of n replacing the 1s, n minus 1 will replace the 1s. And now we can add our t. I'm just going to do it in a different color. I kind of like that. That is not a different color. That's still purple. Okay, so now we can add our t, and we have n minus. Now what can we say, what can we use to replace all of these minus 1, minus 1, minus 1 that happen every single iteration of the recursion? We can do the same thing that we did here. We just replace it with n minus 1. So now t of n is equal to n minus 1 plus t of n minus 1. So again, math tells us that we can just do this. The n's cancel out here. We don't want those anymore. So we don't really want a minus 1 either, so we're just going to say t of 1 because it's absolute. We want it to be absolute for this. Now the goal with the recurrence relation is to essentially get rid of the t inside of your equation. So now we have to try and figure out what t of 1 is. So what happens if we were to plug in 1 for our array here? For its very first step, we would only have an array of 1 cell because we're plugging in 1, right? So that means that this circled line gets called and it has a complexity of 1. So we can just replace t with 1 because t of 1 is just equal to 1. So then we can say n minus 1, t of n is equal to n minus 1 plus 1, and we do just a tiny bit of math. To cancel out these 1s, we end up with n. So that's as simple as we're going to get it. So now we can just pop that into big O notation. So that means that this is our recurrence relation for this little pseudo-code function, and our complexity for it in the end will be O of n. So thanks for watching. I hope this helped out. If there are any questions or suggestions for new videos, you can just post that in the comments, I suppose. And yeah, happy studying.